Hello everyone. In today's video, we will know about Kubernetes Overview. In this video, we will know about what is Kubernetes, why we need Kubernetes and benefits of Kubernetes, architecture of Kubernetes and the Kubernetes Overview, and what are the services we are using in Kubernetes. First is what is Kubernetes. Kubernetes is an open source container management tool that automates container deployment, container scaling, descaling and load balancing. So in a Kubernetes we are also called as a container orchestration tool because it automates deployment, scaling and descaling and also a container load balancing. And it's a flexible working on platforms like AWS, Azure, Google Cloud or even on your own servers. So Kubernetes is also known as K8s. Why we need Kubernetes? Kubernetes will help you manage and run application in container across multiple computers, and it provides healing by automatically restarting failed containers and rescheduling them when their hosts dry. This capability improves the application's availability. One of the benefits of Kubernetes is that it makes building and running complex application much simpler. So it's helps to managing and running the application, and it provide automatically restarting, and the main benefit is that building and running the complex application. So what are the benefits of using Kubernetes? Kubernetes simplifies the orchestration of containerized application, making it an essential tool in DevOps. It's automated deployment and management, scalability, high availability, cost effectiveness, improved developer productivity. So one by one we will know. First is automated deployment and management. If you are using Kubernetes deployment the application, then no need for manual intervention. So Kubernetes will take care of everything like automating the deployment, scaling and containerizing the applications. The next is scalability. You can scale the application containers depending on the incoming traffic. Kubernetes offers horizontal pod scaling. The pods will be scaled automatically depending on the load. The next is availability. You can achieve high availability for your application with the help of Kubernetes, and also it will reduce the latency issues of the end users. The next is cost effectiveness. If there is unnecessary use of infrastructure, the cost will also increase. The Kubernetes will help you to reduce the resources utilization and control the over provisioning of infrastructure. Next is improving developer productivity. Developer can concentrate more on the deploying part. Kubernetes will reduce the efforts of deploying the application. So here we will know about the architecture of Kubernetes. Kubernetes follows the client-server architecture. Here we can see this is the client and server like master node and worker node, where we have master installed on one machine and the node on separate Linux machine. So this is the master and this is the node. It follows the master-slave method, which uses master to manage the Docker containers across multiple Kubernetes nodes. A master and its containers controlled nodes, a Kubernetes clusters. So a developer can deploy application in the Docker containers with an assistance of Kubernetes master. So with the help of the master, developer can easily deploy their application in the Docker container here in the worker node. The main components of Kubernetes, here we can see. The components of Kubernetes are kubectl, API server, scheduler, control manager, etcd, kubelet, kubeproxy, pods and container. One by one we will know. So in the Kubernetes master nodes, first we will explain the master node. Kubernetes master is responsible for managing the entire cluster, coordinates all activities inside the cluster and communication with the worker node. Here we can see API server is connecting with the kubelet, like its communication with the worker node. to keep the Kubernetes and our application running. So this is entry point of all administrative tasks. Master node is the entry point. So first we will know about the API server. This is the one component. API server is entry point of all the REST commands used to control the cluster, and all the administrative tasks are done by API server within the master node. If you want to create, delete, update and display in Kubernetes object, it has to go on through this API server. So API server validates and configures the API objects such as ports, services, replication, controllers and deployment, and it is responsible for exposing the API for every operation. So the next is scheduler. Scheduler, it's a service in the master. So this is also service in the master. It's responsible for distributing the workload. So scheduler mainly helping to distribute the workload. It's tracking the utilization of the working load of each worker node. So scheduler helps to tracking and placing the workload on which resources are available and can accept the workload. The scheduler is responsible for scheduling pods across available nodes depending on the constraints. You mention in the configuration file, it schedules these pods accordingly. The pods are scheduled accordingly. The scheduler helps to scheduling and tracking the which work node is working. The next is controller manager. The controller manager is also known as controllers. It's a daemon that runs a non-terminating loop, and it is responsible for collecting and sending information to API server. So it's collecting the information and also sending the information to API server. It's regulate the Kubernetes cluster by performing lifestyle functions such as namespace creator and lifestyle event, garbage collection, terminated pod garbage collection, cascading deleted garbage collection, node garbage collection and many more. Basically, the controller watches the desired state of the cluster in the current state of the cluster. The next is etcd. It's a distributed key value pair and it's a lightweight. So it's a distributed key value pair and lightweight database in Kubernetes. It's a central database for storing the current cluster state at any point in time, and also use it to store the configuration details such as subnets, configuring maps and programming languages. So etcd mainly helps to storing. The second part is worker node. So in this master node we are using API server, controller, scheduler, etcd and kubectl. In this worker node we will know about kubelet, kubeproxy, pod and docker. The Kubernetes worker node contains all the necessary services to manage the networking between the containers and communicate with the master node and assign the resources to the container scheduled. The components of the Kubernetes worker nodes are one by one we will know. Kubelet. So kubelet is a primary node agent which communication with the master node and execute on each worker node inside the cluster, and it gets the pod specified through API server and execute the container. So it helps to execute the container associated with the pod and ensure the container described in the pods. The next is kubeproxy. Kubeproxy, it's a core networking component inside the Kubernetes cluster, and it is responsible for maintaining entire network configuration. Kubeproxy maintains the distributed network across all the nodes, pods and containers. So it distributed all nodes. So here we can see all the nodes, pods and container, and expose the services across the outside world. The next is pod. So pod is like a group of containers that are deployed together on the same host. Using the one host, we can deploy the containers. With the help of pods, we can deploy multiple dependent containers together. So it acts as a wrapper around these containers. So we can interact and manage this container primarily through pods. Then Docker. So we all already know that Docker is the containerization platform that is used to package your application and all its dependencies together in the form of containers to make sure that your application work seamlessly in any environment, which can be deployment or test production. So because Docker is designed to make it easier to create, deploy and run application using the containers. So this is all about the architecture of Kubernetes. The next is architecture overflow. So users submit desired state via kubectl or API call. So here we can see using this API server, user can decide state. Kube API server validates and updates the desired state in etcd and schedules assign the workload to worker node. So pod helps to assign work node. So controller manager means controller ensure the actual state matches the desired state. Kubelets on worker node pulls images, creators and monitors containers in pod, and kube proxy manages the networking for pod communication. Pods are self-monitored and automatically scaled or healed based on the defined configuration. This entire workflow is designed to be highly automated, scalable and resilient, ensuring that the application remain up running even in the face of failure or increased demand. The next is Kubernetes services. So the Kubernetes have mainly three services. The one is pod, another one is deployment, another one is services. So I have already explained in the architecture. So pod is a group of container. So let's learn about one by one. To view the in this Kubernetes services, to view the components or cluster, we using the command as kubectl get pods -caps A, means all. So and also to view the IP address of pods, we using kubectl get pod -o wide. So when we using this command, we can see the IP addresses of pod and what are the IP addresses are created. So once the pod is created and got assigned with IP, the same IP cannot be used even after. So once pod is deleted or crashed, we cannot use the same IP for viewing the pod. So let's about first is pod. So pod is smallest deployable unit in Kubernetes, and pod is a group of containers that are deployed together on the same host with the help of pods. We can also deploy multiple dependent containers together. So we are using vi-pod.yaml to create a file. So in the demo session, we will know how to deploy or create a pod file and deploying using the Kubernetes. So let's go to your EC2 instance or AWS server. Here go to EC2 instance. So here we need to create the instance. I have already created the instance named as GTS. So you have if you are not created, you can create. So I will just start the instance. Once instance is started or once instance is created, let's connect the instance. So first we need to install the Docker on Kubernetes. So we deploy, first what we need to do is, first we create an instance and connect the instance. The next thing is we need to install the Docker on Kubernetes. So go to install the Docker engine. Here, scroll down. So first we need to install using the apt repository. Before you install Docker engine for the first time on a new host machine, you need to set up the Docker apt repository. So here, copy this, go to your instance, paste here. So Docker is installed. So the next thing is, after install Docker engine, we need to install the Docker packages. Go to this. Yeah, here we can see. So newly installed. So latest version are installed. The next thing is, we need to verify the installation is successfully by running. So copying the sudo docker run. Yeah. So hello from Docker. So Docker installation is successfully verified. So the next thing is, after verifying, we use sudo snap install kubectl classic command. So here we are using sudo snap install kubectl classic command. This command helps so the sudo helps to runs the command with the root privileges. So the snap install the snap package kubectl. So Kubernetes commands line 2, the classic, it install the snap packages with some restriction, and also it helps to enabling the system resources. The sudo snap install command install the kubectl in a Linux system using the snap ensure as the necessary permission to run properly via using the classic. So once installed, you can use the kubectl to interact with the manage and Kubernetes cluster. So to interact with the Kubernetes cluster, we need to install the kubectl packages. So we using the snap to installing. So after can run the command. So kubectl is already installed. To see the kubectl. So I have already installed the kubectl. The next is to install Kubernetes. First we need to install the Minikube. So go to here, Minikube. Installation. So here installation, here we can see operating system I am using as a Linux and architecture. So we can change according to your operating system like Mac OS, Windows. So copy this code and go to instance, paste it here. So Minikube is installing. Yeah. So after Minikube is installing, we need to start the Minikube server. So Minikube start. So here we can see Minikube is started, the version Ubuntu using the Docker driver. So Minikube server is started successfully. So here what we need to do is after Minikube start, we need to copy this Docker group, sudo docker -g docker new group docker, copy this and paste it here. So after that, we again try to start the Minikube. Minikube start. So yeah, here we can see Minikube version. So downloading the Kubernetes. So the next is it's first downloading the Kubernetes. The next is created the Docker container. Yeah. So here we can see kubectl is now configured to use the Minikube cluster. The next we are write a command as kubectl get pods -a. So it lists out all the commands, all the pods it created. Here we can see namespace name. So here we can see all the commands are running state. So this is how we create a pod. So here we can here we see. So we can create a pod like this. So to save this manifest file in the etcb, we are using kubectl apply -f pod manifest, and these commands will create the pod as mentioned in the file. So this here we need to create how to create a pod file. We can see here. So the next is the services is running. The next thing is we here create the pod file. So we are using pi pod.yaml. So here we need to write the code. So that's going to command prompt here. As you write Kubernetes pods copy this YAML file, code instance here, paste the file. So here we are using the file API version v1, kind pod and metadata, name nginx. So we write the file here. Here we are using the API version as v1. So this specify the version of the Kubernetes. So I am using v1 version. The next is we are using the kind pod. This specifies the type of Kubernetes resources being created. So it's a pod and it's a smallest deployment. And here we using the metadata section. It contains the pod, and the metadata contains a pod like a list of names and labels, and here we are using the name as nginx. The next spec, the spec section, it defines the desired state of the pod, and it includes the configuration of the containers. Here we can see the container. Containers will run inside, the container helps to run inside the pod. And the next is the name nginx. I have already told it. The image as nginx 1.14.2, it specifies the Docker image to use for the container, and the ports specify the container will expose, and the container's port as 80. The container is exposing the port number 80, which is commonly used by web servers, and this port will accessible from within the pod. So okay, save and exit. So we can use the command kubectl apply -f pod.yaml. So here we can see pod is created. So first we write the file of pod, then we are using kubectl apply command, so it helps to create the pod. If you want to see created pod, so if you want to see what pod is created, we can use the command as kubectl get pod -o wide. So here the list of the pod is created. Here I have created the nginx pod, so you can go, yeah, here you can see. So to create a pod we use the vi.pod.yaml file. To see this, we are using the get pod -o wide command. The next thing is we have created. The next we can see how to delete the command. Pod, we use the command as kubectl delete pod. So we want to delete this nginx, right? Copy this, paste it here. So here we can, nginx is deleted. So once pod is deleted or crashed, we cannot regain it. This is the main advantages of the pod. So to overcome this issue, we are using the kind deployment. So the next service is deployment. Deployment helps us to create multiple pods, and it's an auto healing feature in case of pod crashes. So to manifest file for deployment, we use the vi pod deployment yaml. So this is the file. So I was shown in practically how to create deployment and write the file. So here let's create the manifest file for deployment. So here we using vi deployment .yaml. So here it's same thing, paste the paste here. So you can scale the number of pods up or down by modifying it, replicas field. And this is why we use deployment. Here we using the version of v1. So app version, it specifies the version of the Kubernetes, and here we using the type of Kubernetes resource being created. Here we using the deployment kind. And the next thing is metadata. It defines the name, labels. So name I am using as Nginx deployment, and the labels is app Nginx. Label is a key value pair used for grouping and selecting the objects in the Kubernetes. The spec section defines the desired state of deployment. Here we using the 3 replicas. Should maintain the 3 replica of pod, and the selector defines how to define the pod that belongs to deployment, and match label. This is the pod to find the label app Nginx. The next is template. The template section defines the specification of pod deployment will create, and this here we using the metadata for labeling the app as Nginx, and the specs. The spec containers create the name Nginx and image as Nginx 1.14.2. It's the image of Docker container. And the port, here we using the container port as 80. It Kubernetes that container inside the port that exposes the port number as 80. The default HTTP port is used by Nginx web server. We are using the default HTTP port. So to save this, set. So the next thing, we need to apply the deployment. So you are using kubectl apply -f deployment.yaml. So here we can see YAML is created. So we can see the created pod. We use kubectl get pods -o wide. So here we can see Nginx deployment is created. So let's try to delete the one pod. So we can use the command as kubectl delete pod, then copy this name. So here we can see Nginx deployment is deleted, and here we can check the pod. So here we can see this pod is deleted and create the new pod. So this is all about the deployment. The next kind is service. So a service is Kubernetes ensures that your applications are easy to access, scalable, and resilient to changes in the underlying infrastructure. In Kubernetes, a service is a method for exposing a network application is running one or more pods in your cluster. In creating the service file, we are using vi-pod-service.yaml. So you can see how to create service. .yaml. Paste. So here we are using the v1 version and the kind of services. This specifies the metadata name as Nginx deployment and the spec selector protocol as TCP, and port we are using 80 and target port is 80. Save this. Exit. So to apply this we are using kubectl apply -f service.yaml. So error converting, so it's error in the YAML file, so we can check. So here we can see kubectl service is created. So after creating the service we need to see the created pod service. So we can use the command as kubectl get pod -o byte. Yeah, here we can see the created pod list. The next thing is, so we use the command as kubectl get svc. So svc is the short form of service in svc. So it lists all the services in current Kubernetes namespace. Here we can see. So this is the Kubernetes and this is Nginx deployment. This is the current service in the Kubernetes namespace. The next command is minikube ssh. This command allow you to open an SSH session into an VM running your minikube Kubernetes cluster. So in the service port we cannot access, so this is the IP address. So in the service port we cannot access a IP address directly. So for that we need to node port. So we need to create a node port first. To create a node port we use the command as bi node service.yaml file. Here we need to create a node port version kind service metadata Nginx deployment spec type. Here we using the type as node port metadata it defines the section. So sorry, after type selector app nginx ports protocol. We are using protocol as TCP. Target port is 80. So here we are creating the node port. Node port as 31,000. So here we are creating the node port. We need to save this. Exit. So node service is created. So we need to apply the kubectl apply -f node service .yaml. So error, it's showing error validating the node service. YAML error validating API version not set. So yeah, you can go to node service. Yeah, here I am typing as app version. It's not app version, it's API version. So then save this. So here now we need to apply resource services. So it's showing error. We need to check what's wrong. I am missing the port. So after protocol here port 80. Exit. Yeah, so here we can see it's configured. I will show you. So see, so service deployment is configured. So after configuring, we use the command as kubectl get spc. So here we can see node port is created. So we can check the IP address, main kube IP. So here we can see, so 192.168.49.2. This is the IP address of the node port. We can use the command curl -l http copy this IP address paste it here. It followed by the port number 31,000, this is the node port. So here we can see, so it's create the nginx file outside. So to enter inside the pod cluster, we are using the command curl HTTP IP address. So this IP address helps to create the file, nginx file. So this is all about how to deploy Kubernetes. Thank you.